Hey, good evening, everybody. Um, I gotta turn off my audio. Wait, let me do a mic check. Okay, good evening. This is Programming Algorithms 2. For those of you who get to be with me twice a week, hopefully you're not getting too tired of me, and hopefully everyone's doing okay. Um, so it's a small crowd of us, but hi, Baby Doll, Longboard, Glazer, Raffle, and hello to everybody else who's here. We're starting week 3, so starting to feel like we're getting into the semester finally. Um, here on week 3. So for the most part, I'm just going to get right into things. But until I feel like we've had a chance to look at the setup of the course in Canvas, I'm just going to remind you of some of the major um, features of our course in Canvas. So we're meeting as usual, 6 to 7 on Tuesdays. You can, if you, I've only had one taker so far, but this confer Zoom link here and also confer Zoom link on the left, those let you book. By default, they're 15-minute blocks, but I don't mind. I will go in a meeting with you as long as it needs if you want to meet with me and look at a project or a lab and you have questions. Unless there's someone else who's booked a time slot right next to yours, then you can have as much time as you need with me to deal with whatever questions you have. Also, of course, the Canvas inbox. If you want to contact me directly and personally, please use the Canvas inbox. That's the inbox here inside of Canvas. And then just to remind you that sort of all of the major stuff, links to all of the weekly content and links to the major projects are all here on the home page. So sooner than later, you should start looking at the first project to start getting a sense of what it is, what skills or techniques you're going to need to address the requirements of that project. So for me, we're in week 3. I will talk about the first project, individual project 1, next week. When we talk about structs is a good time to talk about individual project 1. For your class, all of the weekly content is now available, and all of the projects except for the second team project, which I'm still working on for your class. Good evening, Tyler. So that's all of that stuff. Okay, so I'm going to go into modules, and again, I'm kind of just reminding you how things are set up before we get into the meat of it for the week. So each week, we're in week 3. I've just sort of put the major goals. The goal this week is to practice writing or implementing functions in C++, and then also introduce you to what's called unit testing. If you've done unit testing, which if you've had a programming class with me, you probably have done unit testing. If you've never done unit testing, then this week will be your first chance to get used to what it feels like to run your code against a unit test. So for most of the semester, I use unit tests as a way of evaluating your code. It automates the process for me. For grading purposes, it also sort of gives you feedback as you're working about how correct your code is or not. So we're going to look at a whole bunch of different kinds of C++ functions. I'm actually going to write a unit test so you can see how they are created, and then I'll get you started on this week's lab. The readings, so I just referred to the Xi book, so we have a whole chapter on functions. If you're coming from a language like Python or Go, if you haven't written functions in C++ before, C++ has a whole bunch of different ways of doing functions that most languages don't have. So there's, I don't know, maybe a half dozen different ways that you can write functions, if not more, in C++. I guess if I looked at all of the variants, it would be something like a dozen different 12 or so different setups that you could do with a C++ function. So they are more complex uh, than many other languages, functions in C++. That's just a heads up that you might want to take the time to do the reading, because there is more there than a lot of languages have in terms of functions. So the star of the show will be the lab once we get there, but I'm just stepping through the week's content so you're reminded about how this works. Some people have already turned it in. That's interesting. So this is the lab, and I'm going to come back to this and get us started after I've talked a little bit about functions. In this week's lab, I've actually included a couple of screenshots so that you can, these are from my laptop computer, but it's going to look very similar inside of Replit, and I'll show you that as well. Sorry. So anyway, those screenshots are there just to show you what it looks like when you're not passing all the unit tests with your code, and then when you are passing all the unit tests with your code. The prompt this week, so occasionally I just try to give you a week off because I don't want the prompts, the Piazza discussion to be misery. But I'll remind you that the reason why we're doing the Piazza discussion is because we're trying to recapture some small part of what we'd have if we were all in a room together where we could hear each other talking and we could share ideas and work together. We're trying to capture some little tiny bit of that in Piazza. But this week, instead of doing text, I'm just asking you to log a vote on a poll. You can put notes if you want to, but this is really just meant to give you a breather this week. And then the last element every week is reminders. So reminders about what you're supposed to hopefully have done that week, and then reminders about things that are coming up in the near future. So for now, sooner than later, you should have a look at individual project 1 to get a sense of what's expected. Okay, so there's that. Let's go to Replit. What I'm going to do is just remind you that you can revisit REPLs that you've already created by clicking on this My REPLs link. And I've kind of cleaned mine up just so as we work through the labs week to week, you'll see my REPL sort of grow out with new labs. The reason why individual project 3 is here is because I wanted to load it up and test it to see if it worked correctly inside of Replit, and it does, so that's why that's there. Okay, so let's create a new REPL. C++ REPL, and I'm going to call it Lab 3, because that's, for the most part, what we're going to focus on inside of this REPL. So hello to everybody. I haven't said hello in a bit, but maybe B-Cube, Damien, Daisuke, Longboard, Glazer, Javier, Will Peeper, Raffold, Sugam, you've told me, I think it's Hien. That's Tim Stern and T-Nash. Hello to everybody. Thanks for joining me for this live part of our class. If you're watching the video later, then hope everything's going okay. It looks to me, by the way, from our grading of this week's lab, that pretty much everybody has got everything going real good. So we're pleased to see good results. Okay, so functions. I will point out to you that main, it's probably obvious, but this is a function. And I'm just going to put a template up here to remind you of how functions are set up. So in C++, the way you create a function is you declare a return type for the function. Then you give the function a name. Ooh. Then you have parentheses. Inside of the parentheses, you have parameters. Possibly more than one parameter. And I'm going to say doesn't have to have parameters. what we call parameters. You will have also heard the term arguments, but those are used in a slightly different context. But anyway, every function in C++ has a return type. Every function has a name. Every function has the parentheses, and then optionally, C++ functions have one or more parameters, and then the curly braces, and that's a function template. And then inside, of course, is what the function does. So that's a template for a function, and I'm going to set up a whole bunch of different ones just to sort of get you acclimated to what they look like, and also to point out to you some of the different things that you'll see people doing with functions. So the most simple kind of function is one that has a return type of void. So void here is the return type. This is one of the more difficult concepts to get. It took me forever to realize that what this means, how it works. The idea that some functions return data and other functions don't, that's just a difficult one. So if you're still struggling with that, I totally get that. Took me a long time to figure out what it meant that a function returns something or that it doesn't return something. And I'll do my best to help you with that, but if you see the keyword void in C++ as the return type on a function, that means the function doesn't return anything. All it really does is work inside of its own block of code. So let's just say, we'll say print a greeting. Always the parentheses, so here's the function name. I'm going to use the function name print greeting. I happen to like camel case, but if you like snake case with the underscores, that's fine. Those are two of the more common ones. I happen to like camel case. So you have to have the parentheses, but I'm going to not use any parameters, so I'm taking the option of not having parameters in this case. And then I'm going to print a greeting. So there's what the function does. So this one, all it does is it spits out a greeting. Let me do a little cleanup. Uh-oh. See, there's something funny about, though. There it goes. I'm going to put this using directive in here. That way we can use endl and cout without the standard colon on it. But instead of hello world, I'm going to call my function. So if you've had, which all of you have had, a first semester of programming, you should recognize basically the setup of a function and basically what it looks like when you invoke or call a function. So when the program starts running, it actually goes directly to main and it starts executing whatever it finds in main. So it's going to call my print greeting function, which is going to go into this block of code and execute the code. This void simply means that when I called this function, no data comes back to the place where I called it from. And I'll set up one that does return some data so you can see that. Let's run that, make sure it does run. So there's the hello everybody, which is the output being the work being done by my function. Let me push this down a little bit and check to see how it looks to you. Okay. So that's the simplest kind of function, and if you're in doubt and you are being required to write a function for some reason, start with the simplest setup and then add additional features as they are required. So a non-returning function, the name is whatever you want it to be. You should be descriptive. What does it do? The parameter list, which can be empty but can optionally have things in it, and then what the function does. Okay, so let's do a slightly fancier one. The problem with print greeting here is that it says hello everybody. REPL, it's just misbehaving. There it goes. It says hello everybody every time, and it would be nice if you could print a greeting to someone by name. So I'm going to add a parameter. I'm also probably going to have to include string for this. I just finished, by the way, I was doing a Udemy course in a different language, me as the student, and um, it was noticeable to me how fast they went, so I know that sometimes you're frantically typing to try to keep up. And I'm trying to do my best to balance not going too fast with not wanting to waste your time sitting here while you type. So hopefully I'm doing an okay job at that. Okay, so Little Peeper asked a very good question, which is both of the functions being called the same thing. So you are allowed to do this in C++. I'm going to put a note here. So this is called an overloaded function, and you are allowed to do this in C++. If you've had Go, you are not allowed to do this in Go. Um, okay, thanks, Tyler. Um, so that was a good question that Little Peeper asked. I have the same function name twice, and you are allowed to do that in C++. Not all languages allow you to do what's called function overloading, which is using the same name for a function more than once. So the way this works in C++ is that C++ has to be able to figure out the difference between the two. So C++ will allow this because I have one form of print greeting that has an empty parameter list. So when it sees a call to a print greeting with an empty parameter list, it knows to match that to the print greeting with an empty parameter list. And I have an overloaded one that requires a string as a parameter, and that's how C++ would figure out what it is. So let's do a cout welcome, comma, name. I'm going to greet myself, so now I'm going to go down to main and I'm going to call this function. So I'll just supply a string directly. So since C++ can, the fancy word for this, by the way, is disambiguate. C++ can disambiguate the two functions because it will recognize that one of them has no parameters while the other one has a single string parameter, and it will thus allow the overloaded function to exist and be called that way. Yeah, so if you took the parameter out of the second print greeting, you will get a compiler error because you can't have exactly the same function set up twice. Okay, so there's the welcome everybody from the no parameters print greeting and the welcome void from the has parameters print greeting. Okay, so that's two, and these are going to get pushed off the screen. I apologize for that because I want to sort of run through a handful of examples before I get you started on the third lab. So there's a function that returns nothing. It just does work inside of its own block. Takes no parameters. Here's a function that returns nothing. Does work inside of its block, and it takes a single string parameter. Now let's do one that returns something. Okay, so this setup. So this function is going to return a string. And you'll see how that changes. What this really does is change the way I call this function. So when I call this function, I know that I should expect to get a string back from the function. The name of the function is tell me your name, and it requires no parameters. Okay, so you're going to notice a big difference because this one has to actually send something back to the caller. So the way we do that is the way we do it in most languages. We use a return statement. So this is how the function is going to send this thing back, is with the return statement. It's supposed to return a string, and then I'll just say computer. I'll call it REPL the computer. So that whole thing is the string that the function returns, REPL the computer. So what changes about a function that's non-void, that does return something, is that when you call it, and you'll figure out when you can sort of break these rules, because C++ allows you to break the rules a lot. But generally, if you're about to call a function that gives you something back, then you want to capture that thing you're getting back. Um, so I'm setting up a string variable because I'm about to call a function that returns a string, and I want to capture what the function sends back to me. In a string variable. So this function is going to execute. It's going to return a string to me, and I'm going to take that string that the function sends back to me, and I'm going to store it as a variable called the name here in main. And then I can see out from here I'll take that string that was returned to me by the function, and I will print it out from the place where I called it. So take some getting used to. This is one of the more difficult things I would argue in programming is what does it mean that a function either does or does not return a value? That's just a difficult concept. So if I call tell me your name, what I can see by looking at the function is I'm going to get a string back when I call it. So I call it, I'm going to get a string back, so I assign that to a string variable in the place where I called the function. And then I use that string variable in the place that I called the function. So I'll run that. And there's REPL the computer. So what I'm trying to set up here, by the way, is sort of thinking about if main is kind of me, and these functions are the computer, then I'm having a little conversation here with the computer. So I'm having the computer perform a couple of tasks for me, and then send a string back to me that tells me what the computer's name is, and then I can turn around and use that and print out a greeting to the computer. Okay. So let's do another one. We'll return a string again. I'm going to use two parameters this time. So I'm going to take a person and a computer, and I'm going to return a string that says, hey, they're friends now. So string returning function called make friends, I broke my little spacing rule here, takes two string parameters. If I want to be explicit, I can say that's the person's name. The first argument is meant to be the person's name, and the second one is meant to be the computer's name. But what I will return is the person's name, and I'm just going to build out a big long string. In C++, you can use the plus sign to join strings together. If you've had the Go language, C++ doesn't have the pretty formatted string stuff sort of by default. So there's less pleasant ways that we join strings together and make pretty stuff. But you can take one string, and the act of adding one string to another string just concatenates them or joins them. So Boyd and REPL the computer are friends. Should be okay to do it this way. So I'm just going to take and build a brand new string that we're all friends, and then I'm going to go down to main. I'm going to set up a string variable here, and the reason I'm doing that is because I'm about to call a function that returns a string to me. So I'm going to use the function make friends. I'm going to give it my name, and then Uh, I'm going to use the name I got when I asked the computer, tell me your name. So, and the thing I wanted to point out to you here is that in many cases, you can mix variables and literals into your function calls. Not always, but in most cases, you'll find that you can mix variables and literals as your arguments that you pass to functions. So I call that function. The person name is Boyd. That's me. The name contains the data that I got when I asked the computer to tell me their name. And then I get the result and store it as friends, and then I can just see out whatever that did. Print it out. So there it took my name and the computer's name and made us friends. Okay, so that is, I'll just point out to you here, that's 4 different kinds of functions. And we have more to go, although we're not going to do all of them today, but we are going to do one other kind. I think that we need one other kind for the lab this week. So let's do one other kind, and it's going to be a little intimidating. But it's C++, so the sooner you encounter this, the better, so that you'll recognize later when you see it again. Okay, so I'm going to set up another void returning function. And this is a feature of C++ that I would criticize it for. I think it's too many options, perhaps, and potentially confusing, and can also lead to mistakes. But here we go. So let's see. So notice this is a void function. It's going to take a number, which is an integer, and it's going to double it. I'll just multiply it by 2. You probably recognize that. Most languages have that, the times equals thing. So hopefully that does look familiar to you. Oh, we're getting a good list of people. Hi, everybody. I think I said hello to everybody. If I didn't, hello. Okay, so void, double the number. So one thing that you should immediately, maybe you don't, but you will eventually, you'll immediately recognize that the work that this function does is completely meaningless right now because that data never leaves the function. This is a function that does not return data. It takes a number, it doubles it, and then it dies there. Totally meaningless. And I'll prove that to you. I'll create a number here. We'll just make the number 5, and then I will call double the number and pass it this parameter number, and then I will see out the number afterward. So I create a number, its initial value is 5. Then I pass it to double the number, which in theory at least doubles it, and then I'm going to print it out. Notice, by the way, when I called the function, I did not set up to capture any return value because it doesn't return anything. It just does work internally. But you'll see that when it does work entirely internally, it doesn't actually change anything. The number stayed 5, even though the function did the work of doubling it. So what I'm going to show you is something that you should definitely not abuse. But you're going to see it because I want you to be aware of what it is and what it means when you see this. Hopefully everyone's seeing that the number actually never got doubled. So the reason why it didn't get doubled is because parameters in this format are basically copies of the originals. So when the function is called, it receives a number and it produces for itself a copy of that number. So this number times equals 2 is being executed against the function's own copy of that variable. What that means then is that I have in main number, which I set to 5. I pass that to double the number, but what happens as soon as I call the function is that it generates a copy of my number, its value. So it takes my 5 and it doubles it, and that's the end of it. The function, that's it. When it comes back from the function, my original number is left untouched because the function was working on a copy. There is a term for this, by the way. This is called pass by value. I think it's easier to teach an understanding of it if I get people to recognize that it's being passed as a copy. But pass by value means the value, a copy of the variable, not the original variable. So we're going to put something in here, an ampersand, and that changes this parameter. So without the parameter, without the ampersand, this is a pass by value, a copy of whatever that is. If I put an ampersand in here, the function will no longer work on a copy. It will actually reach through and work on the original value. This is called pass by reference. That's what the ampersand does. That's pretty subtle. That kind of stuff can drive you batty about programming. That's very, very subtle. If you miss the fact that that ampersand was there and you thought that a function was just going to work on a copy and it ends up actually destroying your variable, that's irritating. So be on the lookout for this thing, because that usually means no copies being made. They're working on the original. So this function is receiving a reference back to the original variable. So it means that when it doubles it, it's doubling not its own copy of number, but the original of wherever that came from. And we'll prove that by running this here. So notice now, after I run the program, my number here in main has been doubled, and that's because the function received its parameter by reference, which allowed it to sort of reach across and alter the original. Yes. So Tyler has a variant of this. So Tyler's is better. So this is, in my opinion, bad unless you can't avoid it. And I'll show you a situation where you can't avoid it. So if you can possibly avoid these ampersands, do it. And Tyler in chat has a good example of this. So let me comment these out. A much better way to do this is to implement the function so that it takes a copy but returns an updated piece of data so that the caller can do with that what they want. So we're going to return number times 2. I did it a little bit more clipped down from Tyler's, but Tyler's had it exactly right. You can. Okay, I'll go back to that, baby doll. Okay, so let me comment this out and deal with the question about this one. So this ampersand, you will see people put it, there's 3 places you can put it, and it means the same thing. So you can butt it right up against the data type of the parameter, or you can put it as a space between the data type and the parameter, or you can butt it up against the parameter's own name. And you'll see programmers do that in different ways. I put it typically to the left because I want to think to myself it's an integer reference. But you will see programmers put it and argue that you should put it in all of those different places. I like to butt it up against the data type. So good question. Okay, so, oh, by the way, what I'm doing in Replit is I'm highlighting these 3 lines and I'm doing control /, which comments out the whole block. And I'm highlighting these and I'm doing control /, and that undoes a comment. So this is the better way to do this. It's always better to take parameters by value, copies of them, and return new data from the function if the function is computing new data. This is always the better way to do it, but I'll show you a situation where that's a problem. Okay, so that is by far the better way to do it, and the reason why it's better to do it that way is because when you call it, that gives you the option of keeping your original variable intact and instead making a new variable that contains the updated value. So I could say the old number is number, and then the updated number is so this is why this is desirable, is because the programmer who's calling your function may not want you to destroy their original variable. It's much better if you give them the option. So I could have said I'm okay with destroying my original variable and just taken whatever the function returns and overwritten my original. But it's always better to give Control Z to undo. It's always better to give other programmers the option of keeping their original data and taking your calculated values and storing them separately as updated values instead. So this is the superior approach, but I'll show you an example of where we run short, where sometimes we have no choice but to do it. Okay, so there's I got to keep my old number because the function was the nice one that Tyler wrote, and it let me instead create a new variable to contain the updated value that the function computed for me. That is the better way to do it. Okay, but now let's look at a situation where we can't necessarily do that thing. So let's say we have a function that's, how do we want to say this, breakdown seconds. Let's say that someone's going to give us like, how many hours, minutes, and seconds is 10,000 seconds? So we could say, let's return how many hours it is. So let's see, how many hours? What's the calculation to turn seconds into hours? Is it divided by 3,600? I think it's divided by 3,600. So that's seconds per hour. So if I have that many seconds and I divide it by that, that tells me how many hours are in there. So I can get the hours part broken down. In fact, let's say get hours, minutes, seconds off of a seconds. So if you come from the Go language, Go will let you do something that C++ will not let you do. In Go, I can actually return all three things from a function. In C++, I cannot. C++ will let you return one thing, and only one thing. Now, there are sort of object-oriented tricks to work around this. So I'll answer that. Let me answer this question on chat, and then I'll come back to this thing. So a question on chat is declaring functions above, making the declarations above main and the bodies below main. That's actually my preferred style, and I'll show everyone what we're talking about. I'll adapt this to the other style. So my preferred style is actually to make the declarations of functions above main and the definitions below. But when I'm teaching on Twitch, I do the functions above main to save space on the screen. But I'll come back to that question about declaring and defining in a second, so that everyone can see what they're asking about, what that looks like. Okay, so if you come from Go, you may remember that in the Go language you can return multiple things from a function, but in C++ you cannot. You cannot do that. So this is a problem. in C++. If I want to get the hours, minutes, and seconds out of this function, but I can only get one thing out of the function, well, how could I do that? And what you'll see a lot of people do is use the pass by reference trick. So what I can do is I can't have the word seconds in there twice. So let's call this the input. So where you will see people use this by reference trick is sometimes to get around the limitation that they need to compute more than one value in a function. So if I have 3 pass by reference parameters, I effectively can compute all 3 in the function. So I converted this into a void because I'm no longer going to return things. And now here's the tricky part. I have to remember that when I receive a parameter by reference, it's actually a reference back to someone else's variable. So I don't want to declare an hours variable. I just want to use the hours variable that has been sent in to me by reference. And the reason why they would have done that is because they understand that I'm probably going to put the value for hours in there. And then minutes should be the input divided by 3600. Nope, mod 3600 divided by 60 minutes per second. So this is take out all the hours. What's left, divide that by 60 should give me the minutes. And then the seconds, the computed seconds, will be take out the hours, take out the minutes, and everything that is left is the seconds. So I hope that makes sense a little bit. You're going to see this in the lab. So if you're just returning one computed piece of data, then you definitely use the return value for that. But there are occasions where you would like to compute multiple values. And in C++, one of the more direct ways that you can do that is to simply have the caller give you references to variables, and then you load up those variables with computed data. So notice I'm not declaring hours here because that is already coming in as a reference to someone else's variable. So the other trick here, and you're going to see me call this function in a second. Notice this first one is by value. It's a copy, and that's fine. I don't want that for, I'm not going to change that value. I'm just using it to make a calculation. So you try to keep the by reference stuff to a minimum as much as possible. Now hours, minutes, and seconds, I need to be able to compute and store data in those variables, so those are all passed by reference. Okay, so now let's look at how that would be called from down here. So the caller's job is to provide some value for input and then 3 variables to hold the results. Yes, you could. So maybe it'll ask you could actually return a string and also sort of compute and set up data through these parameters, and you definitely can do that, and you'll see people do that as well. So you could return one kind of data and then use your parameters to compute and store values that'll let you sort of kind of return additional values and different data types. Yeah. Just don't overuse it because it's an easy place to make a mistake. But you definitely could do that. Okay, so let's look at what does it feel like to call one of these functions. So to call a function that takes reference parameters, you actually have to have variables for those. So I'm going to make hours, minutes, and you don't overuse this either, but as we go I'll just show you things that I like to do. So there's hours initialized to 0, minutes initialized to 0, seconds initialized to 0. Those are all integers. Then I'm going to call that function. It does not return anything, so I don't have to set up to capture any return value. Instead, let's just put 10,000 seconds in there. And then my hours, minutes, seconds. So as the caller of this function, I understand that the function just needs that value, which it will make a copy of, but it's going to actually load up its calculation results. 37. Oh, good catch. Yeah, I forgot the assignment operator. Good catch. Thank you. I mean, Replit was trying to tell me that, but I didn't see it. Thank you, baby doll. Okay. Yeah, I was missing the assignment statement, and Replit saw it. Okay, so there's my three variables. So the caller of a function like this has to provide the right kind of data. Reference parameters always have to be variables because the function is going to overwrite their values with new ones. Value parameters can be variables or literal data because the function is going to just make a copy of it anyway. And then I can say cout. So we'll do how many hours, comma, minutes, comma, seconds. If I didn't do the math right, you can point it out, or I think that's probably right, but I didn't really think it through real hard. Okay, so that's 2 hours, 46 minutes, and 40 seconds. The point there is that the function actually computed, and because those are passed by reference parameters, I actually got the data back inside of those variables that I passed in by reference. Okay, so that's one of the more difficult ones. So there's another question that I'm going to address before we do a little bit of setup on lab 3. So what you see me do here is I've placed the functions, all of them, I've placed above main. But there is another way to do it in C++. I know this is a lot to take in, although I guess it's being recorded on video, so you could always go back and pick up on the spot that you wanted to look at again. There is another way to do this, and we will do this in this semester, but someone asked the question, so I'll show it to you. So another way of setting up functions in the C++ program is, I'll just do print greeting as an example. So one thing you can do, let me copy this. So I'm going to Control C this to copy it before I do what I'm about to do. One thing you can do in C++ is you can make a function declaration at the top of the file. A function declaration is basically the first line of the function followed by a semicolon. And notice the block with the curly braces is gone. So this is how you would declare a function. And what you're telling C++ is, in my program, I'm going to have a void returning function called printGreeting that takes no parameters. But you haven't said yet what it is that it's going to do when it's executed. So in C++, you can declare a function at the top, and then you can, way down at the bottom, here's main, way down at the bottom below main, you can actually put the actual definition of the function below main. And this is a very common technique. I'm not doing it that way just to save screen real estate while we're on Twitch, but I'll go ahead and finish. Am I going to finish the thought? Maybe. So what you will see often, I'll just do it. No. So the question is, do I prefer that you do it this way? And honestly, I don't care as long as you give me neat, stylistically consistent and working code. So if you prefer to do it this way, where you declare at the top and define at the bottom, you can, but typically I'm not going to require either of those styles. You do it how you like. So you can just do definitions at the top, or you can, Replit's just giving me all kinds of hassle. I think I copied it. But I wanted you to see what this looks like because you will see people do it. So here's another declaration at the top, definition at the bottom. So the question is this a good habit? Ultimately, it is a good habit to do it this way. And the reason why it's a good habit to do it this way is because eventually you're going to be writing libraries of code for yourself and other people. And generally, when we communicate what our libraries contain and what they're capable of, the only thing that we tend to communicate is the declaration parts of our function and not the definition. So when we share code with each other as programmers, we usually just show this part of the function and a note about what it is that'll happen, because how it actually did it, no one cares about. Right? You care about it because you're learning how to program, but when you get out, start working in larger projects, um, you're not necessarily going to want to see how another programmer wrote their code all the time. You just want to know, like, what are the functions and how do they work, not what are they doing inside of there. So it is a good habit ultimately to be in. I probably don't need to do the whole thing, but I'm going to move the declaration down, leave or definition down, leave the declaration at the top, and so on. Um, so the two ways to do it. Yes, that's true. So if you have a larger program where you have lots and lots of functions, this can really save you eye strain, because this will just kind of remind you of what your functions are, and you don't really have to remember exactly how they work. Yeah, you just have to remember how you would call them and what's going to happen if you do. That's a good point. Okay. Do I want to keep this stuff? I should better keep this stuff. Uh, okay, so I have a few minutes left. I want to help you get started on the third lab. So I showed you a whole bunch of different kinds of functions here. These aren't all of them. You're going to see functions in different contexts. So once we start doing object-oriented C++, you're going to see functions appear in different places. There are a couple more techniques we can use with functions. In fact, you'll probably see another half dozen different setups over the course of the semester. But this is a lot of sort of the main ways that you can set up functions to work in C++. C++ has a lot of symbols in it, which just makes it a hard language to get comfortable with. Okay, so I'm going to move this code to the side. This is something you can do as well, by the way. Basically, I'm going to cut all this, and then I'm going to make a new file and just call it backup.txt, and I'm going to paste all that stuff in it. So that way I have a file. It's not a C++ file, so Repl.it's not going to try to execute it, but I have all that work backed up somewhere while I move on to other things. So that's why that file is there. I clicked on this add file icon to do that. Okay, we do have a few minutes, so I can get you started and maybe show you a little bit about what the unit tests do. So let's go look at the lab. I'm just switching tabs here. We're in week 3, so let me go back to the lab. Okay, so I've already done this part. I'm not talking about this anymore, but remember, inside of Repl.it you can change the settings, you can change the theme and where the terminal goes and that kind of stuff. Okay, so let's start dealing with instruction 3, which is go get some code. I think we've done this, but let's go grab some code and overwrite our main in our lab 3 REPL with it. The way I like to do this, so you can at this stage just highlight all this stuff. The faster way to do it is to click this raw button here, which gives you only the code. So Control A to select all, Control C to copy, and then I'm going to go over to my Repl.it tab. I'm going to make sure that main.cpp is highlighted. I've already emptied it of its original contents, and then Control V, Victor, to paste in the lab. So that's step 1. And right now it's not going to work. It won't even compile. But that's actually step 3 in the lab. But the first thing in the REPL is to get the code that sets up for the lab. Okay, go back to the lab and close this one. I don't need that one anymore. Go back to the lab page. Step 4 is to get another file. So this time it wants me to add a new file and name it doctest.h. Now I'm going to save myself a step here. I'm going to go copy and grab the code first. So we're going to add an additional file of code this time. Um, so this doctest.h is the library that we will use to write unit tests. So it's another file of code. This one's quite long. It's probably 10,000 lines, or how long is it? 6,000 lines. Anyway, raw is a lot easier. Control A to select all. Control C to copy. And then I'm going to go to my REPL. I'm going to create a new file. It's called doctest.h. I made a typo there. I also want you to look inside of my main. You can see right here it says include doctest.h. So that's what this file is going to be. So please make sure that you spell it correctly, because if you don't spell this new file the same as what it's being called inside of main, you're going to get compiler errors. So doctest.h, and I did originally make a typo, so I fixed it. Press enter. Now it opens doctest.h. I'm going to control V as in Victor, control V to paste all that stuff. And I'm done with doctest. That needs to be here, but you don't need to ever touch the code inside of it. In fact, there's even a warning at the top that says don't. Don't do that. Okay, so that's the setup. Remember, backup is where I put just my sample code from earlier. I have doctest.h, that's our unit testing library, and then I have main.cpp where I pasted in the lab. So do I have time? Maybe I have time. Let me undo. Okay, I know what I'll do. So that's the setup. Now I'm going to just show you a small example of what's going on here. Your job is to complete the implementation of these functions. So I actually showed you a function that does something similar to this, where you sort of put pieces together to build a string. This one has a trick to it. It has to have an if-else statement, because this name may be empty. So you have to be prepared for that. Here's one that returns a string. This one returns a Boolean. It takes a numerator and it checks to see if this denominator is a factor of that numerator. Modulo on this one. Here's make change. I also showed you an example of this. So notice I have one by value parameter and then a whole bunch of by reference parameters. And in fact, in this case, I put them on the other side. Unsigned integer, by the way, that just means it can't be negative. And if you were to try to make it negative, the compiler would either catch it or it would have errors at runtime. So those are meant to be positive, 0 and above numbers. But notice that's kind of like that hours, minutes, seconds thing that we did. These two are just looking up how do you convert a Celsius temperature. REPL, it's acting funny. How do you convert a Celsius temperature into a Fahrenheit temperature and return that Fahrenheit temperature? And this one is convert a Fahrenheit temperature into a Celsius temperature and return that Celsius temperature. And then all this stuff down here, you'll see there's a note here, do not alter. All this stuff is code that I've written to call your functions. So here's a call to the greet function, and to see if it's returning what I expect it to return. And you can sort of work your way down. So here's greet with an empty name, should return a string that says nice to meet you. Greet with an actual name should return nice to meet you, Jane. Is factor, so it should be true that 25 is a factor of 100, and it should return false that 24 is a factor of 100. So your challenge is to write these functions correctly so that the tests pass. So let's just look at what it looks like to fail, and I'll help you get started. So let's just make this one return nothing to start. And I'm actually going to go down the list and do this over and over again. So this one, let's just have it return a nothing string. This bool, let's just have it always return false to start. This one I don't have to return anything. It's a void returning function. This Celsius one, let's just have it return 0 to start. It needs to be a double. And this Fahrenheit one, same thing. Let's have it return 0 to start. Now our job is to come back here and actually write the code so that these functions are actually correct. Okay, but let's run it, and we're going to see the unit test is going to run all those functions through a battery of tests, and we'll see if we're passing any of them. So I'm going to click run. It does take a little bit longer because all the testing code, that 6,000 line library, has to be compiled in. Okay, so here's the results of my test. I have passed, as it turns out, 6 of the checks, and I am failing 10 of them. So without even doing any work, I'm sort of just lucking into passing 6 of them. Overall, I'm failing the overall test. So I passed 0 of the overall tests and failed. You'll see some of these I put multiple test sections in there. So that's what a unit test looks like when you are failing it. Do you see a skip somewhere? Something skipped. Oh, okay. No, I know what you're talking about. So Baby Doll's noticing like where's the output for the ones that are passing. So by default, you can only ever see the ones that you fail until you pass them all. But I'll show you a little trick here. Yeah, it actually ran them all, but you're not seeing like what happened to the ones that we passed. And there's a trick you can use for that. So down here in this screen, I'm actually going to type clear. I'm typing clear in this screen to clear that off. So you can actually do some commands inside of here. So one thing you can do, I think I might do this wrong. You can actually manually run your own program. When you click run, let me run it again. I just want to show you something and then show you where I'm getting this next thing from. So I haven't changed anything, I'm just running it again, but I want to show you something at the top of the screen. So see this right here? That's Replit actually running my program. So turns out that you can run your program for yourself. So you can actually type /main in here, but if you put a -s, I think, you actually get a display that shows your successes and your failures. So by default, the testing is going to show only your failures. But if you put a -s, then you'll see the ones where you're succeeding also. So now they're all here. If I scroll up, you can see it started way up here. So I failed 3 in a row. You can actually see where in the code the tests are happening. So there's a test on line 48 that I'm failing, but there's a test on line 52 that I'm passing. So by default, you're only going to see the ones that you fail and not the ones that you get success. But if you want to see success, I'm typing clear. Yeah, it's encouraging because sometimes you want to know like, well, which ones did I pass? So let me go give you enough to, let's start fixing one of them, and then let's see if we can pass it. So this first one, let's pick this one off so we can see the results. So right now I'm passing 6 and failing 10. Okay, so if this parameter is an empty string, return nice to meet you. So this function needs an if else statement. Yeah, Baby Doll's right. So most of the labs have these tests attached to them. So once you get used to using the unit tests, you're going to know whether or not your lab's perfect because you're either going to pass them all or you're going to fail some. And the way we grade these, if you're failing some, is we divide 100 by the number of tests and we take off points per each test that you fail. Um, okay, so this one needs an if statement, and in C++, the way you God, REPL, it's just acting so weird. Do you see that? How it's um, so if this name, so the way you get the length, the number of characters in a string is you use dot size. So I'm going to get the size of that string. If it's 0, meaning it has no characters in it, then I've been told to return nice to meet you with a dot on it. And unless it tells me a line break at the end, I'm not going to put one. So it's told me if the size of the name string is 0, no characters in it, empty, just say nice to meet you. Otherwise, I'm supposed to return a string nice to meet you, comma, name. So I will return a string that is nice to meet you, comma, space, plus the name, the parameter, and also a dot at the end. So tack that on as well. That's the other thing. So I kind of just did that part for you. But now we can run the unit tests again, and let's see how we're doing with the greet tests. And the reason why there's a lag here is because the unit testing is more code, so it takes a little bit longer to compile. So I am now passing 8. I'm passing 2 that I wasn't before. I'm still failing 8. And if you remember, I'm going to type clear to clear the screen. If I want to see the successes and the failure, I can put /main space -s, which will show me where I'm succeeding. So I succeeded on the name was empty part. I succeeded on the name was Jane part. So I'm passing the 2 tests for greet. Now I'm failing one of the is factor tests and just accidentally passing the other because I don't actually have any code that's doing anything. I'm also failing the change making function where it's testing to see how many quarters, dimes, nickels, and pennies, and then it does another test again. Although actually magically I'm passing the second set of them just by accident. And then of the Celsius to Fahrenheit, I'm failing both. Fahrenheit to Celsius, I am accidentally passing one of them, even though I haven't written any code. So that's called unit testing. I will show you during our time together how to write these for yourself if you're interested. Also, just so you may want to know how did I make these. That's a good question, Baby Doll. So name.size equals 0 is the way I would do it. That's the way my mind thinks, but it is perfectly fine to say name equals nothing. Now, I will tell you why I don't do it this way. So this will work. It'll work just fine. But what can happen is you type this and accidentally a space gets in there and you don't notice it. And all of a sudden that's no longer the same condition. So for me, I feel like it's a more of a sure thing to say how many actual characters are in it as opposed to but what you're saying with the name equals empty quotes, that does also work, and there's nothing wrong with it. This just happens to be my preferred way of doing this problem. Okay, I'm about done. I will write some unit tests so you can watch me put those together from scratch so that you know how they're done. I don't have you write any of these for yourself this semester. I encourage you to try it. But this is becoming a big deal in our industry. A lot of us believe that this programming with the assistance of these tests to make sure that our functions are uh, correct, basically, is a good way to do programming. So you will see and hear talk of them more as you get out there and do more learning, or you get out there and you get into a job. Hopefully, you're working for someone who appreciates the value of the unit test. But this is a way basically to just subject a set of functions to some basic diagnostic testing to make sure that they are basically correct. Okay, that's it for me for this week's lecture. I'll sit here for a couple minutes and answer questions if you have any. I'm going to scroll back up while I do that. So here's the one function that I finished. Okay, so you are in groups, although to be honest, I don't know how that looks from the student's perspective, but for the first team project, you already do have groups, and I don't know what that looks like for students. Um, but I have created groups for you, and I don't know what that looks like. That's a dang good question. Let's see if I can find an answer to that real quick. How do I view my groups as a student? I think oh, there's a groups thing. I don't know if that's going to be true or not. Um, so you are in groups, and I don't have it because I'm not in a group, and I don't have a means of accessing any of your accounts. But in theory, it might be under the people link. I don't want to click on that because it might show student information if I do, but maybe someone can help me out with that and either Canvas inbox me or because honestly I've never as a student in Canvas done a group thing, but the groups have been created. They're randomized, and most of them have 4 people in them, I think, and they are connected to the first team project. So on the app, your group looks like a class on the main home page. Oh, thank you, Glazer. So, for iPhone. Okay, so it is findable on iPhone. Let's see if there's a picture of it here. Global navigation. It says if you have a groups link, you might be able to click on a groups link and find that you have a group associated with this class. Where did you find it, baby doll? Okay, so under groups, people. So the groups are there. If someone has in your group, we've only lost one person. So if you are short a person, I can step in and be that extra person, or I can help you by taking them from one of the groups that has it. There's a couple of groups that may have an extra person, and I can shift one of those people to your group. Um, so the groups are created. I think for the most part, you'll find that it's relatively easy. Mostly I want it to be about the experience of kind of collaborating with other programmers with multiple files on a project. And there's not very many functions to implement. Um, but I need to look into that more because I'm not sure how. I'll take it about that. Ah, okay. Yeah, if your team is short a person, I'll do that. Of course, I'll try to push the rest of the group to do the more interesting things. Okay, so I think we're good. If you can get in and look at the team project, at some point do that. When it becomes a more pressing issue, when we get within 3 to 4 weeks of it, you'll start seeing reminders about it on the reminders page. It's not a super long one. It's not meant to strain anybody. It's really meant to give you that first experience of having code that you wrote that has to interoperate with other people's code. Okay, I think I'm done. Canvas inbox. confer Zoom if uh, anyone wants to ask me one-on-one questions. Thanks, you too, little peeper. Have a nice evening. Thank you, everybody, for being here, and take care, everybody. If you're watching video later, take advantage of discussion and uh, the Zoom office hours and the Canvas inbox if you need. Um, anyway, everyone, be good. Have a good evening. Hope the rest of your week is as good as it can be, and I'll see you on Tuesday next week.